Hey, physical science kids, Mr. Tima here with a little help on Bohr model, the actual drawing uh, practice. Now, the Bohr model, remember, is just flat out. Oh, I got to turn my pen on. See, all this technology. Bohr model is just flat out a practice of what we're going to do. And you got some practice like this online, and then you also have a worksheet that kind of looks like this if you're in my class. But basically, the first thing we have to do is we need to look at our periodic table, either the link online or you can search up any periodic table and put it up on a tab. But we want to find the atomic number. And remember, the atomic number is always the smaller of the two numbers, okay? And in the notes, you can help find that. But sodium has an atomic number of 11, which means it has 11 protons. You know what? I'm going to zoom. Oh, excuse me. I'm going to zoom in on this so that it's easier to see. Okay, but we're going to zoom in on this sodium. There we go. All right, but it has 11 protons, 11p plus, which equals 11 electrons. Okay, so I always like to do the electron configuration so I know I'm right. And if you've been doing that, you know that that's going to be 2, comma 8, comma 1, because 2 made it 9, then 8, take 8 away, and that made 1. Okay, and that has to do with 2 in the first shell, 8 in the second's the max. There's 8. There's room for 8 on the third, but there's only 1 left. So again, the answer is 2, comma 8, comma 1. So when we draw that though, and it really doesn't matter right now where the X's go, the middle dot represents the nucleus. This is your nucleus, okay? And so we're just going to put 2 on the first shell. That's now full. 1, 2, 3, 4, 5, 6, 7, 8, and there's 1 on the outermost shell. Again, you're going to start pairing these up when we go to Lewis dots and things like that, but for right now, we just kind of want to get them in the right shell. All right, potassium, which is K, it's going to change up, but potassium, K, if you look up there, potassium has 19 protons. Man, that's a lot. All right, that means we have 19 electrons. Take a second and see if you can do the electron configuration. Some of you might be getting really good at this and figuring out the pattern that the first two are full. We're at 10 already. All right, the next one's 18, and now we have 1 left over. Again, if we slow that down, 19. There's 2 on the first floor. Okay, that leaves me with 17 electrons. I have 17 people. I can fit 8 on the next floor. Boom, I'm down to 9 electrons. 8 can fit on the third floor. Well, I got 8, so I'm going to put 8 up there, and that leaves me with 1. Okay, well, I can fit 8 on the fourth floor, but I only got 1, so I'm going to put it up there. And again, if we're filling this out, that'd be 2. We try to put them on the lines as best we can. As you can tell, writing on the computer is a little tough. And then we want to put 8. 1, 2, 3, 4, 5, 6, 7, and 8. Then 8 on the third. There's 4, 5, 6, 7, 8, and we have 1 left over. Okay, out there with room for 1, 2, 3, 4, 5, 6, 7 more. There's still room for 7 more. All right, let's try one more. See if you can find hydrogen on the periodic table. Hydrogen's the king, man. He's number 1, which means he has 1 proton. Okay, he has 1 proton. All right, and that 1 proton, that equals 1 electron. Electron configuration, how many can fit in the first shell? 2. I only got how many people over at the house? 1. So my electron configuration is 1. Well, that's pretty easy. Bang. Okay? So again, that's pretty much what's going on here. That's pretty much how you do this worksheet and figuring it out, / examples online. If you have more questions, and there may be more shells than you need on some of these, but I just drew them on there so you'd have them. Other than that, always reach out if you have a question. Otherwise, Mr. Team is here. We're all here if you need help. Talk to you later.